一个挑战。只要它解决，就能全面无障碍推进，见证奇迹的时刻。对了，大家看到扫描器上面出来了吧？我的天 ，OK 了，真的 OK 了。我的天呐，研究了好几天。OK， 那么现在我们先继续把这个厄拉赫星给它调查好，然后我们转头就回到这个Jemison。行星的转轴倾角越大，一年中白昼黑夜长度的变化就越大。话说这个1我们做了什么？还没给名字，这个叫什么呀？重力异常，图片飞絮，暂且叫这个名字 ，in progress。备注重力异常点1。现在我们这样以后就可以直接用 X Translator。两边直接给它打开，然后 load 我们的 ESM， 我们的这个 unique location names， 然后我们就可以直接按照名字来排，直接找到这个重力异常点。给我瞎了。这我瞎 ，What the fuck？ 为什么有2个？我看我怎么命的名啊？我真的是，我想给自己来2拳。等一下，靠！我真的想给前几天命名的自己来2拳。你就不能把它命名成 A、B、C？ 你为什么要把它命名成？当然，这个不是什么大问题，因为我们还是可以直接改。我直接把这个进一步区分啊，你是2，你是3，你是4，你是5，你是6，然后我 save， 我怎么 save 来着？哦 ，finalize。万事计划，也不知道要推进到什么时候，别真要推进到1万事，这辈子都做不完就不，那是不可能的。当然，要真的是全身心的投入这项工作，别的游戏都不玩的话，我觉得1个月、2个月应该是能做完的。但是我要玩别的游戏，我还要上课，那就不好说了。那这个。实际上，你看我每周3巨头循环，每周7天3个游戏循环，也就是每周 每周最多有3次玩星空的机会，最低有2次玩星空的机会。然后每一次会有5个小时，也就是每周我能玩10到15小时的星空。如果这个是一天每天玩10个小时，现在刚开始的那个样子，没有任何别的游戏的话，那速度会比现在快很多倍。它还是1，它就是1就是1。哎呦，我没有要开枪的意思，不要这样。重力异常点1 ID。这个 ID， 我们还有一个，哎，我不是应该还加了一条吗？地点旁边，它怎么没有啊？对啊 ，Editor ID 呢？是我没看到吧？哦，在这儿，Editor ID 这边我们也要写，这样才能完整确定它的地方到底在哪。然后我们就可以正式的把它的名字改成重力异常湖片废墟。接下来我们就可以回归一边探索一边做的节奏里，因为外面的技术准备已经完成。或者说重力异常湖片废墟自燃，还是异常重力湖片废墟自燃？我不得不想问问大家这件事情。但是这些东西以后都可以改，无所谓，现在不用在乎。现在我们要尽可能的多找几个地点，这才是最重要的。包重。
To what do I owe this pleasure? I am happy to help shoulder. I will be here for you, as always.
话说现在育碧游戏在打折，我今天进了22款育碧游戏，而且我感觉我也不会玩，就是我每一个都是我觉得，哎，我有点想玩，但是我不认为我的时间允许我去玩他们的任何一款。反正我全买了，但是至于什么时候玩，那就不知道。星翼又来了，主要是他现在来了还是不吓人，不知道为什么。他的船又卖不了，没有人要他的船，让我非常的尴尬。这边长得不一样。左轮可真好看，我现在一直在欣赏这把左轮，它后面的那6个那个柄，那个叫什么弹夹的地方，还有几个小金属片，那种蜂窝一样的形状是真好看。而且星空里的每一把武器好像上面都有这个沉浸式 UI。
No indigenous life signs. One less thing to worry about, I suppose.
重力异常点3。青岛之湖，我觉得不要叫重力异常点，没劲这个名字，我们要改改。3号是吧？让我想一想，你叫什么？青岛之塔。重力异常点3，准备登记。3号，3号的editor ID。我只是在采矿而已，没必要大惊小怪。采矿，我们是快乐的矿工。这个采矿真的舒服，哎，这个采矿用惯了以后好爽。咱们这个回的有点慢，我也不想用量子精华。飞船着陆点，我要注意一件事情，是只有星翼飞船着陆的叫着陆点，还是别的都叫着陆点？因为我记得有叫着陆区域，好吧，我也不太清楚。它确实到本地以后也是飞船着陆点。重力场点1，沉淀卡帕，天然，这是什么？好像给人家拍一些好点的照片。之前拍的有点太随意了，我要重拍，重拍，说干就干，要拍专业一点的。之前拍的是什么东西，真的是太难看了。咱们一定要认真对待每一件事情，要拍就好好拍，不能凑合。 换成这个。可惜你改名不能在游戏里实时呈现。对了，我还有一个问题要研究，就是如何显示所有地点。这个应该是有办法，只是目前没看到有别人做这个 mod， 我打算自己开始挑战。不过前提是我要把人家那个教程看了。好，那这么一看的话，今天又没空玩，所以我还是先让我玩一会儿吧，好吧？也不能本末倒置，玩游戏还是为了玩，做 mod 那是叫什么？那个支线任务，光顾着做 mod 玩不到游戏了，岂不是很离谱的事情？被掩盖的火山坑，这个应该之前是记。啊，没拍照片，可能有这种事情。这倒不需要，不需要。山洞 H 过去看。话说我的 NASA 电台呢 ？NASA 来一下，上次听到哪儿了 ？NASA Podcast， 我都忘了我之前听到哪。On a Mission 吧。完了，完全忘了。哎呀，啊，这集我听过。也，哼，这个那换一个吧。如果我自己都不知道听到哪里了的话，那我们听。这个，等等，这是什么啊？这是西班牙语啊！啊，这个， Curious Universe. Our universe is wild and wonderful place. Join NASA astronauts, scientists, and engineers on a new adventure each episode. All you need is your curiosity. First-time space explorers welcome. NASA's Curious Universe is an official NASA podcast. 它都是道，那我们就从第1季开始。Listen.
This is really what you get into science for. It's for moments like this. You're ready, your team is ready, and these things happen at random moments, and so you have to be ready when opportunity knocks.
Everything we've seen has been surprising. Just the sheer amount of structure in the solar wind. The fact that when we first saw the magnetic field data, the first worry was, oh no, is the instrument malfunctioning?
Hello, Houston. We are inspired. We are ready. Let's go fix this thing.
Sounds like a good plan, Endeavor. Good morning.
It's changed everything we know about the universe, the planets in our solar system, the way that stars are born, live, die, the most distant galaxies. This is one of the grand adventures of NASA.
Sometimes the blanket person, we might be the last ones to touch the spacecraft before it launches.
It's a real sense of awe, I think, that we find in the natural world, and there are many different places you can find it.
Being out there on your own in a spacesuit, looking back at the planet, you're really in this self-contained life support system, really your own little spaceship.
Welcome to NASA's Curious Universe. Our universe is a wild and wonderful place, and in this podcast, NASA is your tour guide. Subscribe right now and get ready for a grand adventure.
要自己跳吗？看来是。Only on Earth.
One of my favorite places on Earth is one of the most beautiful parts of the Amazon basin that I've ever had the privilege of visiting. There's a national forest right next to the Tapajós River, and it's a place we've long studied in the central Brazilian Amazon. Inside the national forest, we've built a tower that allows you to walk
这是 NASA 的广播 ，NASA 的播客。
into the air. As you walk the steps of this metal tower, you finally step out into the sunlight in the top of the canopy. You're surrounded by an ocean of green. And in every direction you look, you're seeing the vivid colors of the tropical rainforest canopy.
和我们面前的景象形成了鲜明对
It's
比。
really striking to me to be able
死
to
寂
feel
和生期，
so immersed in that environment from the forest floor all the way to the canopy. And if you're sitting there at sunset, when the macaws are coming into roost, the monkeys are making their last calls for friends or food, it's a really peaceful and alive place. It just reminds us that there are fascinating things yet to discover on our planet.
Welcome to NASA's Curious Universe. Our universe is a wild and wonderful place, and in this podcast, NASA is your tour guide.
I'm a research scientist,
earth scientist, project scientist
at NASA.
When you think of NASA, you might think of all the incredible mysteries of outer space. We're also pretty invested in another very special place. I'm Patty Boyd, and in this episode, join me on an exploration of one of the most fascinating places in the solar system, Earth. This April is the 50th anniversary of Earth Day, and we're explaining some of the ways NASA keeps an eye on our home planet.
21
Sometimes here at NASA, we like to say that every day is Earth Day.
That's Doug Morton. He's one of the many Earth scientists at NASA.
Studying our home planet has always been a really important
哎，
part
对，
of
这个
NASA's
特别
mission.
爽。
NASA
哈哈
has
一边
so
漫
many
游星
different
球，一边
ways
听
to
NASA
study
广
our
播，
planet.
太舒服
And as
了
a。scientist, it's my job to think about
尽
which
享
of
眼
those
前之
different
景，
measurements
尽
are
享耳
important
边
for
之声，
the questions I'd like to look at.
都和宇宙有
Think of
关，
all the amazing parts
都
of
和
our
太空
planet.
有。
Earth is home to volcanoes, deep oceans, sprawling deserts, and growing cities. It's the only planet we know of that can sustain life. That's a lot to keep track of, and everything is connected. NASA's Earth scientists work to monitor and measure these systems so we can better understand how our home planet functions and how it's changing.
NASA's satellite data records really tell the story of our changing planet. In the last 30 years, we've watched the polar ice caps shrink. We've actually been able to estimate the amount of water that's been lost from glaciers and ice sheets by weighing water from space. We've been able to track changes in forests from natural disturbances like hurricanes or wildfires, or the expansion of agriculture that shifted production of grains and crops from places like the Midwest United States to the frontier of the Amazon basin. We've been able to track changes in our atmosphere that relate to how volcanoes put sulfate particles high into the stratosphere, or how the ozone hole has actually been shrinking over the time record of our satellite data. Each of these scientific discoveries really depends on having the knowledge of our home planet, as well as the information and the regular, carefully calibrated and collected measurements we take from space to track those changes over time.
Those carefully calibrated measurements can help scientists like Doug gather information about our planet and predict patterns for the future.
From space, NASA has a really unique role to play in terms of how we understand our home planet. Our scientists have designed instruments to be able to take measurements of our atmosphere, our oceans, ice cover, and vegetation. And as we put those pieces of the puzzle together, we're able to look at our entire Earth as a system, all of its complexity.
NASA has a global view of living ecosystems, both on land and in the sea, something made possible by satellites. With that view, we can see the effects of our changing planet on the life cycles of things like forests and plants. We can even track wildfire outbreaks in remote areas, sometimes before first responders on the ground. NASA Earth scientists study all sorts of things.
One of my areas of research is how wildfires are changing our planet. Really, someplace on Earth is always on fire, and our NASA satellites are often the first to detect those fires, and of course to track their changes. What do those fires mean for people living in communities close to the fire? Where does the smoke from those fires go? And how might it impact people living in cities far away, as well as the greenhouse gases that build up in our atmosphere?
We can understand a lot about Earth from space. We can use scientific instruments to help us learn about things like air pollution. Anne-Marie Eldering, a scientist at NASA's Jet Propulsion Laboratory in Pasadena, California, works on one of those tools.
A lot of folks know about the NASA work focused on solar system and Mars and planets, and they don't realize how much we're doing about our home planet. The International Space Station has been flying around our Earth for quite some time, but people maybe don't know too much about what's going on up there. I'm the project scientist on the orbiting carbon observatory 3. That's an instrument that's installed on the International Space Station to measure carbon dioxide around the globe.
Before she came to NASA to work as an Earth scientist, Anne-Marie wanted to be an engineer.
It's only when I came out to Los Angeles and saw the beautiful smog that was here in the 1980s did I realize, you know what, air pollution is my calling. It felt exciting because it was a tangible problem I could see, and the questions we were going to answer were actually going to make an impact. There's sort of 2 or 3 things that are most critical to the work that we do, and one of those is the measurements from our instrument from OCO3. What we look at is we see that sunlight is gone through the Earth's atmosphere, reflected off of the Earth's surface, and then comes back to our instrument. And so we measure this amount of light, and every molecule in the world interacts with light in a very unique way. So if you measure the light really carefully, you can learn about how much carbon dioxide was in the atmosphere.
怎么说呢？
With
它
this
是什么呢？
technology,
它是
scientists can get a deeper look at complex gas
它是一
mixtures
个
and
太空
particles
探
that could be
索
harmful
沙
to
盒
human health.
RPG。
They can figure out the sources of dangerous air
辐射
quality
呢
and
不
how
是
to
一个
improve
太
it.
空探索游戏，天外世界
Scientists
其实
aren't
也不是
just
太空
interested
探
in
索游戏，
surveilling the planet.
同时它也
They
不是
want to
沙
be able
盒。
to use the information gathered to look towards the future.
When we think about our Earth and the climate of Earth,
其实没有什么和它类似
climate
的，
is
说实话。
changing, but one of the things that's been difficult to do is really predict well what it will be like in 2040 or 2050. So in my mind, when we're thinking about the kids today and what the world's going to be like for them, we want to have some more information to understand that better. And the data we collect is going to help us understand how carbon dioxide flows through the plants and the ocean and the atmosphere. And when we understand more about how it's moving around, we'll be able to tell you more precisely what 2050 might be like.
Understanding Earth gives us the means to better protect it. NASA scientists travel to some of the most dynamic places on our planet to bring back information that helps us understand Earth. And in turn, that information helps us understand our whole universe.
Some of the measurements we can make from space are incredibly valuable, but many other measurements have to be taken on the ground. NASA scientists today are actually spread all over the world. We have a team of people out studying snow in the high mountains in Colorado. We're about to send off a team to the mud flats on the south side of the Everglades National Park to understand how mangroves that were damaged by Hurricane Irma have recovered in the last 2 years.
等我到了下个洞以后，我要
We're
把
sending
船
teams
叫
of people to Africa to understand how dust that
搞一个
blows
平
from
的地
Africa makes its way all the way around the globe,
这里
fertilizes places as far away as the Amazon. My first trip into the Amazon, I remember sort of being overwhelmed not just by the kind of emotion of arriving finally at the forest frontier, but also the activity. As you step into the forest, you're struck by the fact that the forest environment it's cooler, it's more humid, and it's alive with sounds.
没有
You get the chorus and calls, birds and primates, frogs and other species that just remind you that you're stepping into a world that has thousands and thousands of species, many of which we've not even discovered or described. It's a real sense of awe, I think, that we find in the natural world, and there are many different places you can find it. So we're in the field with our colleagues making
但我现在确实很难说，我最喜欢的游戏到底是辐射4还是星空。我觉得这两个在我心里的地位差不多。如果你问的是这个意思的话，
tells us something unique and different.
虽然其实他们两个玩起来的节奏区别比我预想的要大得多。
NASA scientists are working really across the globe, and we're using a number of different tools to study the planet and how it's changing.
At NASA, there are actually entire divisions and missions completely dedicated to Earth science. From wildfires to sea level rise, there's a lot to keep an eye on. The data that NASA collects makes a record of our home.
One of the exciting things working here at NASA is that we have a long record of satellite observations, and that actually allows us to go back in time. When we think about the ways in which we're studying our planet and its changes, my first thought is we can begin in the 70s, the 80s, and start to step forward in time until the present. And that's a really powerful way to look at our planet. And one of the things I think that's a really important foundation for a lot of the work we do going forward is that we do have this long time series of measurements: ice cover, vegetation, land use and agriculture, changes in oceans and atmosphere properties. And that long time series really is the basis on which we're understanding the subtle but important changes in our planet.
其实这里不会有敌人，因为这个星球是没有活物的。我们其实不用这么小心，谁动我一下，别吓我。
We know more about why Arctic sea ice is shrinking and the loss of water from the Antarctic and Greenland ice sheets. Both of these things are major causes for sea level rise, and we've learned that based on a long record of data.
这个洞穴的样子像是被什么气体还是水蚀了一样的。它这个它的岩壁上都像那种波浪状，感觉是冰或者水侵蚀过的样子。
built really important connections with the farming community,
wildfire
and disaster response communities, and a number of other applications that really depend on having information in near real time to respond to ongoing changes. Whether you're a farmer trying to understand whether you need to irrigate or fertilize your field, or you're a firefighter trying to figure out where the next blaze started and how you're going to respond to protect a community in the hills of California. That's where the information that comes in from our satellites today is so valuable for making decisions today. And of course, every day of observations continues our long data record of observations that helps put today's changes in the context of the past.
Doug and Anne-Marie are just two of the many Earth scientists who study our planet each day and monitor its changes.
Too much on.
It's hard not to be overwhelmed by the magnitude of many of the recent changes. Someone who studies wildfire, right in the mix of that emotional swirl of wanting to help people in need, of wanting to understand the changes, and as well unable to ignore the consequences of fires, whether they're happening in Australia, the Amazon, or Alaska. Every year from space, we map more than 1 million large wildfires. Every one of those wildfires is important to a community. It doesn't have to be the world's biggest, fastest, hottest, or most extreme fire to be important. I think that's something we always try to keep in perspective, but there are days when it's difficult. It's a lot to manage the emotions of the fact that those 1 million wildfires are doing damages to communities, are changing air quality for people near and far, and are part of the way in which our planet is responding to warming and drying conditions.
You know, by nature, I'm actually a fairly optimistic person. I always somehow manage to find a way to think, well, there's an opportunity for change, an opportunity to advance, and that's the road we're going to take. Certainly when you study things like climate and air pollution, you can see the change over time, and there's some things that we see improving, and there's some things that aren't really improving. But I feel like people are engaged in these questions. They're thinking about the choices they make and the impact it has. So I remain optimistic that people want to learn, they want to understand, and they want to make a good decision in the big picture.
I think it's important to remember that there are scientists at NASA and really across the world whose primary goal is to keep tabs on what's happening on Earth every day. I think that's reassuring. It's exciting to have a momentous occasion like the 50th celebration of Earth Day. I think to really look back at how much we've learned over those 50 years and how much we have yet to do in terms of our collective action in safeguarding our home planet. It's really exciting to think about what we'll learn and do over the next 10, 20, or 50 years. In a way, it's almost impossible to imagine, and I think that's the exciting part about working at a place like NASA, where we're always thinking about the future and where the possibilities seem pretty endless.
Earth is a truly incredible place, and seeing our planet from space gave us a new appreciation of it. In 1968, astronauts on board Apollo 8 were orbiting our moon when they spotted something incredible on the horizon.
Oh, yeah, look at that picture over there.
A bright blue marble rising over the dusty lunar surface.
Wow, that's pretty.
That voice? It's astronaut Bill Anders.
Got a color film, Jim?
He doesn't know it yet, but he's about to take one of the most iconic photos of all time.
Give me a roll of color quick. Oh, man, that's great.
Earthrise. A reminder that we're all in this together. On this Earth Day, it's important to remember how special our planet really is. After all, we only have one.
It's amazing when you stop and think about it, the variety of life forms that exist and the temperatures that are perfect for us and the way the atmosphere protects us from the UV radiation. I mean, it's really actually pretty astounding that the Earth creates this habitat where we and all the life forms of the Earth can exist. What a wonder.
This is NASA's Curious Universe. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to Leslie Mullen, Colin McNutt, Michael Pallas, and Danielle Rappaport. If you like this Curious Universe episode, please let us know by leaving a review or tweeting about the show at NASA. Take a deeper dive by checking out the show notes. Join us next week as we explore a historic NASA mission, the Hubble Space Telescope, our window to the stars.
哈勃望远镜 Our window to the stars.
All know what it's like to wander outside and look up at the night sky. On a clear night, when you can see all of the stars perfectly, it's so easy to feel small. It makes you wonder, what's out there?
What's out there?
Beyond what we can see.
还是这句话
The Hubble Space Telescope has helped us answer that question over the last 30 years, revealing that reality is often stranger than fiction. We've seen the births and deaths of stars, and we've found answers to questions we'd never even thought to ask before. We've learned all of this in incredible detail by looking back in time.
Hubble is like a time machine in the sense that we can look farther and farther out into the universe at these fainter and fainter, more distant galaxies. And by doing that, we're really looking back in time because it has taken time for that light to get to us from these stars and galaxies.
That's Jennifer Wiseman. She's the senior project scientist for Hubble and says that the telescope is achieving more than scientists originally expected.
Hubble has recently contributed to the determination that the expansion of the universe is, in fact, accelerating. That was unexpected. Hubble has become the pioneering telescope in analyzing the atmospheres of exoplanets. Hubble has found the likely presence of water in moons around other planets using interesting, innovative techniques. That was really not something Hubble was originally designed for. So we're using Hubble now for kinds of science we did not originally anticipate.
And after all this time, the discoveries we get from Hubble every day are still knocking us back, telling us more about the nature of our universe and its origins. But Hubble's journey to the stars was a difficult one. So how did it succeed? Welcome to NASA's Curious Universe. I'm Patty Boyd, and in this episode, we're exploring a truly iconic NASA mission, the Hubble Space Telescope, our window to the stars. This is the story of how NASA put a telescope in space. Decades before the Hubble Space Telescope was even a possibility, the idea of looking beyond our own atmosphere was at the forefront of astronomy. Back then, most astronomers believed that the universe consisted of just one galaxy, our own Milky Way. Then, Edwin Hubble came along and changed everything. From a mountaintop near Los Angeles, he peered up at the night sky with a ground-based telescope, the Hooker telescope, which at the time was the largest one in the world. That's when he spotted something amazing. The fuzzy objects he noticed in our sky were actually other galaxies. And most of these galaxies he spotted looked like they were moving away from each other.
Edwin Hubble was one of the pioneers that determined that our universe is in fact expanding. Galaxies seem to be moving apart from each other along with that stretching of space. But we couldn't quite discern the rate of that expansion. It's a very difficult measurement. So the Hubble Space Telescope was able to contribute to a really higher precision measurement of that expansion rate by measuring more carefully the distances of these galaxies and correlating that with other measurements of their apparent velocities and giving us an expansion rate that was much more refined than anything ever before.
Edwin's discoveries made scientists wonder. If we could see all that coming from a ground-based telescope, what would happen if we sent one above our murky atmosphere? German scientist Hermann Oberth dreamed of what we might learn.
If we could look at the heavens with an astronomical telescope in orbit, unhindered by the shielding sea of atmosphere that blankets the Earth, think of the discoveries we would make, the clear vision of the universe we would have.
Echoing Oberth's vision, astronomer Lyman Spitzer outlined the details for how to make it all work.
刚才改名已经生效了，
that
非常
would
好。
really set the stage for
我们
Hubble.
隔一会儿重启一下游戏，
NASA
检查一
set
下
out
进
on an
度。
adventure to place a telescope in space.
现在就很爽。
This telescope would discover things that would revolutionize the way we think of our place in space. Here's what the great astronomer Carl Sagan had to say about this bold experiment.
Space telescope is, in a way, a little like Galileo's first telescope. Wherever Galileo pointed his telescope, he made major new discoveries. Look at the moon, find mountains and craters. Look at Saturn, you find rings. Look at the Milky Way,
Mountains and craters.
Find it is littered and oozed of stars.
我们现在眼
Every
前
one of
就
these
是
discoveries, things that people had not known before. I think it's going to be very similar with the space telescope. It will illuminate
佩特里亚
celestial
星的
objects
月
that
球。
we know about. It will discover celestial objects never before guessed. It will provide insights into the most important questions such as stellar evolution, such as the search for planets going around other stars, and the grandest cosmological questions of the origin, nature, and fate of the universe. Space telescope is a kind of grand intellectual adventure for all of us, which will cast light not just on the cosmos, but also on ourselves.
The telescope was built at Lockheed Martin in California, with NASA's Marshall Space Flight Center overseeing the telescope's construction. It was named after Edwin Hubble, who paved the way for grand discovery. But actually getting a telescope the size of a school bus into space is difficult, as you might imagine. That's where the Space Shuttle Discovery comes in. NASA's space shuttles were designed to carry and deploy spacecraft like Hubble. With the Space Shuttle Discovery, NASA astronauts would deploy Hubble at the edge of space in low Earth orbit and return safely to Earth. NASA designed the telescope to fit snugly inside Shuttle Discovery, which carried and released this precious cargo into space.
The Shuttle Discovery, poised at Cape Canaveral for a launch tomorrow morning. It may be the most ambitious and eagerly awaited mission in the history of the shuttle program. On board a giant telescope that will redefine our view of the universe.
When it launched in 1990, NASA's Hubble Space Telescope was only designed to last 15 years. In 2020, the telescope celebrates its 30th birthday, and Hubble is still as powerful as ever.
Hubble makes discoveries 24 hours a day. It's up there orbiting the Earth, and it goes around the Earth about once every 90 minutes. And so...
That's Michelle Thaler, an astronomer and science communicator at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Goddard is home to Hubble's mission control.
The Hubble Space Telescope is something that just changed everything. I think people now have this view, what does space look like? And they don't even realize that what they're thinking of is something that Hubble images brought to our culture, to our imagination.
She's right. When you close your eyes and imagine space, you probably picture stars, beautiful colors, and a sheer vastness. The images that pop into your head are probably stars and powerful clouds of nebulas. That's because the pictures taken by the Hubble Space Telescope are the clearest and closest we've ever come to looking at our universe. They've fundamentally shaped how we think of space. And from space, Hubble can see a lot. Here's one way of looking at it. Imagine going to a piano concert, and the musician sits down and can only play 3 notes around middle C. That's the amount of light we can see here on Earth. Then there's a whole spectrum of light our eyes aren't sensitive to. And that's where Hubble comes in. Hubble can see in multiple wavelengths of light, like infrared and ultraviolet. So Hubble's view would sound a lot more like a symphony. NASA made a huge push in the years leading up to Hubble's launch to promote the revolutionary telescope's efforts. NASA promised the public that this project would lead to important discoveries and answers. After all, this was the culmination of decades of work and research, not to mention the financial and emotional investments riding on this mission. On April 24th, 1990, the telescope launched.
3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Back on Earth, Mission Control monitored the deployment carefully. They knew what was at stake.
And this is Hubble Telescope Control in Greenbelt. We have been given the go-ahead to begin commanding release of the forward latches, which hold the solar arrays in place.
When the Discovery crew set out to deploy the telescope, they were under a lot of pressure. After all, Hubble was set to be the greatest astronomical advancement since Galileo picked up a telescope. But something went wrong.
Of course, when Hubble finally got up and everybody was really excited, there was this amazing sense of deflation when they opened up the telescope, light went through it, and they realized the images were out of focus. And they were out of focus because the curvature of the mirror was wrong. So, I mean, this was just an incredible mistake. People have been making very accurate telescope mirrors for a long time. And the fact that all of a sudden, up in space, what were we going to do now? You know, this incredibly valuable instrument. Tremendous problem. The first pictures that NASA saw here on Earth were fuzzy and distorted. And it
我们
was
现在
all
头
because
顶
of
在
an
游戏里看到这片
incredibly
星
small,
空，
almost
当然不知
undetectable
道具体
aberration,
这个材质是哪
a
来的。
tiny error
不
from when
过
the mirror was constructed.
反正这一切的源头
Hubble's
哈勃望远
vision
镜。
was blurry. But the telescope was still technically doing its
所以他们
job,
还是
at
以某
least
种
as far
方
as
式有
astronomers
关
like
系，
Michelle were concerned.
或者说我们对太空的
Still worked just fine.
一切想象
The
很
images
大
were
程
out
度
of
上都
focus,
归
but
功于
all
哈
of
勃
the
望远镜。
data, you know, the really detailed data about the universe was still coming in through these spectroscopic instruments. So,
说不定我们头顶看到的那片星空就是来自于哈勃望远镜，说不准，不知道。但是不是没有这个可能性。
But of course we wanted to get
所以我们
those
现在
clear
听哈勃望远
images
镜
to
的
see
播
the
客，
universe without the distortions of the
很有感
atmosphere, to
觉。
see it beautifully, beautifully clear.
From the beginning, Hubble was designed to work hand in hand with the Space Shuttle program. NASA had anticipated that Hubble would need to be modified and expected to send astronauts to do so in the coming years.
What was not anticipated was that the first images coming from the Hubble Space Telescope were quite disappointing. There was obviously a problem.
System optics. The conclusion we've come to from that is that there's a significant spherical aberration appears to be present in the optics, in the optical telescope.
The mirror on Hubble had been ground beautifully, but to a slightly incorrect formula, and this had not been caught in testing.
This incredible idea was raised, you know, why don't we fix it? And then this is one of the grand adventures of NASA.
NASA set out on a daring rescue mission to save the Hubble Space Telescope.
They came up with a very insightful solution. Basically, in some sense, it's been described as putting glasses on Hubble.
These glasses were actually an instrument which was designed to correct Hubble's flaw. A team of astronauts were prepared to service the telescope in space.
Hello, Houston. We are inspired. We are ready. Let's go fix this thing.
Sounds like a good plan, Endeavor. Good morning.
They made an instrument that actually corrected the light as before it went into the cameras, took out the wrong curvature.
Okay, I'm in 1 inch. You're in 1 inch, and I have it. You have it? Yes, I have it. Okay, I'm going to let go.
All of a sudden, things snapped into just beautiful, beautiful focus. Everything was gorgeous. So it is one of the most amazing happy endings in the history of science, in the history of technology.
Hubble's servicing missions didn't stop with its initial rescue. Over the years, Hubble has been serviced multiple times. John Grunsfeld is one of the astronauts who helped keep Hubble in top shape.
For me as an astronomer, going out in a spacesuit and working on the Hubble is just the ultimate experience. There's nothing cooler. Hubble is an incredible icon of science, and so To me, it was the holy grail of being an astronaut.
John worked on 3 repair missions to the telescope, earning the nickname Hubble's Keeper from publications like the New York Times.
I was expecting, the wonders of space and the beauty of the Earth. What surprised me the most was that I kind of discovered my humanity. That being in a tight crew, working together as a team with hundreds, thousands of folks on the ground, that there's really nothing, I think, that humans can't achieve if we work together as a team, and if we have good challenges, things that are worth doing, we can do almost anything.
We know so much about our universe now because of people like John. People who were watchful stewards of the telescope and who dedicated themselves to its success.
Hello, love.
Hubble has lasted
Need to
a
see
lot
what
longer than we expected. We thought Hubble might last 10 or 15 years if we were lucky.
Goodbye, dearest.
But thanks to the series of astronaut servicing missions over the years, the telescope has been refreshed over and over again with repaired instruments and new batteries and gyroscopes and things like that, refreshed new instruments as well. And that has made the telescope basically brand new, more or less, every time we've done a servicing mission, and that's kept it at the forefront of scientific discovery.
To get a look at the outstanding
Oh,
imagery from the Hubble Space Telescope, visit nasa.gov/Hubble. You can also follow the telescope on social media at NASA Hubble.
结束了。
This is NASA's Curious Universe. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to the Hubble Space Telescope team. If you're enjoying Curious Universe, consider leaving a review on your podcast app or tweeting about the show at NASA. And in the next episode, astronaut Nick Hague
看前情提要，直接开始。The astronaut training pool， 这个训练以及选拔池，看来是谈这个如何成为宇航员。
The neutral buoyancy lab, or the pool as I like to call it, it's a really remarkable place. It's so massive, 200 feet long, 100 feet wide. And the water is crystal clear.
他们说的是游泳池。
Divers have started to get in the water yet.
是那个适应低重力的，在水池里面，因为在水里有浮力嘛。他们是在水里进行训练。
And so you get to see the magnitude of what you're going to go down and work on here shortly.
我还以为是那种选举池子，结果是字面意思上的水池。
experience. When I first came down here, that was when I first put on the spacesuit.
穿着宇航服在水池里。
water and started floating around in the water. It felt like this is astronaut training.
宇航员训练是从水池里开始。
I'm an astronaut at NASA. I explore space for a living.
I explore space for a living.
NASA's Curious
地球上没有几个人能说出这么霸气的话。
Our universe is a wild and wonderful place.
他刚才说的是我靠探索太空吃饭。我好羡慕。
NASA is your tour guide.
地球上没有几个人能说出这句话。
We're exploring the underwater training ground where astronauts train for space. There are humans in space right now. In fact, humans have lived in space continuously for nearly 20 years on board the International Space Station.
This International Space Station, it is gigantic. Imagine this space station floating around with these gigantic solar arrays, these wings of solar cells that are collecting the sun's energy, and that's how we power the station. It's the size of a football stadium. On the inside, it's got kind of the volume of a large jumbo jet, and so that's the area we live and work in. we're up there, you know, it took 100 launches and it took 100 spacewalks to put this thing together. And we've been up there living inside the station. It's been inhabited continually for 2 decades now.
The space station orbits around Earth, about 250 miles above ground. The international crew that lives and works on board is doing critical research that can't be done anywhere else.
We're up there trying to perform this science because on the space station, gravity isn't the dominant force.
立刻投降，我们是连职的人。
Around you, everything around you is controlled by gravity. Everything in the room you're sitting in is held down to a table or to a floor because of gravity. And up there, all that goes away. And that's when we can make some really key scientific discoveries.
The ISS is a unique place to study human health and medicine, on top of the more obvious scientific questions about astronomy and meteorology. Weightlessness helps us understand the possibilities for long-term human space exploration. And it helps us understand life here on Earth a little better, too.
Our job, working on the space station, is to go up there and perform science experiments and try to discover new things, whether those are new materials that might help people on the ground or those may be new medical breakthroughs that might help people on the ground. And so we're up there constantly kind of pushing the boundary of what we know, helping the scientists on the ground make those breakthrough discoveries. It's allowing us to learn more about ourselves, the human body, about the universe around us, and how to improve life on the ground, and also how to take those discoveries and push further into the unknown, into space.
Before embarking to a place where very few humans have been, astronauts train for 2 years. In that short time, they're required to learn a lot more than you might expect.
Astronaut training in a nutshell is you need to be a jack of all trades. You need to be able to do a little bit of everything.
Repairing and servicing the International Space Station, learning Russian, and receiving medical training.
Learning Russian.
Astronauts must be prepared for every possible scenario. But before an astronaut ever sets foot aboard the space station, they have to train somewhere you might not expect. This isn't just any old swimming pool. It's the Neutral Buoyancy Lab, located at NASA's Johnson Space Center in Houston, Texas. This special pool contains 6.2 million gallons of water, enough to fit 9 Olympic-sized pools inside. It's where astronauts like Nick come to train.
So the pool is this gigantic pool. It's 200 feet long, it's 100 feet wide, and it's 40 feet deep. It is enormous. It's still not big enough to fit the entire space station in it, but it fits full-scale, large chunks of the station so that we can practice, and that's our training ground.
The pool is where astronauts first get acquainted with the armor that protects them from space, their spacesuit. And that can be its own challenge. First thing, you've got to suit up. It can take about 45 minutes and the assistance of multiple suit technicians to get the suit on, checking to make sure that every piece is fitted and working properly, from the helmet locking into place to the gloves fitting around every finger.
You have to learn how to use the spacesuit because it's not like wearing clothes. It's constraining and it limits some of the things you can do. It's fatiguing because of the pressure of having it stiff, and so you have to learn how to use it, and that takes hours underwater getting to know your spacesuit.
Once you have the suit on and it's been double and triple checked, you can prepare to enter the Neutral Buoyancy Lab. Even though you're not out in space just yet, the pool will simulate what you might feel once you're out there. Why? Because being underwater simulates weightlessness.
The Neutral Buoyancy Lab is there to train us because that's one of the places or one of the ways that we can try to simulate being weightless. So that idea of neutral buoyancy.
It's called neutral buoyancy because when you're in water and you don't sink, but also you don't float, you're completely neutral. It's like you're hovering in place.
And so it feels as though I'm weightless, and I can maneuver myself around the outside of the space station and have the experience of working in a weightless environment. And so we're constantly trying to balance out the weight of an object with its buoyancy so that things just float in front of you.
Weights and flotation devices are carefully combined to let astronauts feel what it's like to be weightless in space. When an astronaut is training in the pool, their backpack, the primary life support subsystem, is filled with air they can breathe and instruments that monitor their health.
You've got to get everything straight, because once you go underwater, that's all you've got are the tools you took with you. And you're going to be down there for 6 hours.
That's about the amount of time it takes for a spacewalk in actual space. Once you're in the pool, waterproof instructions are attached to your arm, and you rehearse the spacewalk as if you were doing the real thing.
All right. Nick, before we get started on that, if we can just help me guide that out.
The whole time, a team of people is watching every movement of your practice spacewalk. They monitor the pressure inside the suit and the temperature. And the test director is making sure that the whole process is going according to plan.
Good teamwork there. Exactly.
So I need to float a little bit higher on this end. Okay, so that's...
领航员这套好看。
Trained scuba divers guide you around a replica of the outside of the International Space Station.
Yeah, and that looks good here. Yeah, we're aligned down here.
Having this full-size mock-up of the space station underwater allows us to essentially memorize where every handrail is, where every handhold is. And if I'm going to work in a particular location on orbit, I will have seen that and understand that location on the ground.
Astronauts are explorers, and a pretty big part of their job is going on spacewalks.
We practice doing spacewalks so that when we need to go outside and fix something or increase a capability, add some new piece of equipment, we're ready to do that.
During a spacewalk, the only thing that stands between an astronaut and the vacuum of space is their spacesuit. And while they're attached to the outside of the International Space Station, they're orbiting the Earth at 5 miles a second. That's like driving from Boston all the way to Philadelphia in just 1 minute. It's difficult to replicate the sensation of being in space. But with the Neutral Buoyancy Lab, NASA can get pretty close.
I gotta tell you, when I did my first spacewalk, shortly after we went out the hatch, the sun set and it got dark. And it felt exactly like I was in the pool. To the point where I remember having the thought go through my head, where are all the bubbles? Because normally in the pool you see all the bubbles from people breathing underwater. It was one of those things I was like, wow, this is so close to what we're doing underwater in the NBL. It's just amazing training.
失重的感觉和水下的感觉这么像，宇航员甚至认为一模一样。
Without the protection of the Earth's
所以大家
atmosphere,
可以去
the temperature can either
水池
soar
里
or
体验
plummet by a range of over 500 degrees. And there's only a little bit of time to get through your to-do list. 6.5 hours is the usual ballpark for a spacewalk.
See you
And
later.
that might sound like a lot of time, but remember, there's a finite amount of oxygen in your tank. You need to keep track of the power in your battery and monitor water for spacesuit cooling. And most importantly, you have to watch your carbon dioxide levels. The longer you're in space, the more likely you are to get hit by flying debris. Micrometeoroids are a spacesuit's worst enemy. Even a piece of metal that's as small as a grain of sand can puncture your suit, which could cause air to leak out. Astronauts train for a wide range of scenarios they might encounter during all phases of their journey, from launch to the return to Earth. There's a lot that could go wrong, and Nick knows that firsthand.
2, 1, and there is liftoff of the Soyuz MS-10 to the International Space Station, carrying Nick Hague and Alexei Ovchinin. Again, is Nick Hague's first launch to space.
We train so that we can respond to the unknown.
这 哦
We are constantly
我
not
手
just
柄
training
我手柄
for
断
when
了，
things
突
go
然
right.
他人
We're constantly training
What the
against what we
fuck?
can predict will go
他
wrong.
自己在往
In the training scenario, we're fighting 5 or 6 different major failures so that we have the bandwidth to be able to, on a real flight, to
红莲
handle the one big thing that's thrown at you.
Hearing there that there has been an issue with the booster, and we're standing by for information as we continue to get it from the Russian flight control team.
I can tell you in that moment, when life throws something at you like that, it is amazing how you just revert into that
用不了了。
mindset of, hey, I was being vigilant up to this point.
The fuck?
I've diagnosed something that's wrong. We know what we need to do. This is our best way of being successful. And then you follow those procedures as best you can. And you're able to kind of block, you know, a lot of the other stuff out and focus on just what you need to do to survive.
Everything seems to be fine with the crew. We had good comm with them, and they are okay. We continue to wait for more information.
At that moment, Nick remembered his training.
We had an in-flight abort. We recovered from that one, and I was able to launch successfully to the space station about 5 months after that.
Nick ended up having a successful and productive trip to the International Space Station, thanks in part to his training at the Neutral Buoyancy Lab.
The International Space Station, that international aspect of it is really a powerful part of the program. You've got astronauts that have been from 19 different countries, astronauts and cosmonauts working up there together. We've, been able to perform 2,800 different experiments from researchers, like 4,000 researchers from over 100 different countries. It has this ability to bring all of these very different people together in pursuit of that common goal of increasing human understanding.
Nick returned to Earth last fall, and he treasures his memories from his time in space.
What it has really taught me is that when we understand this common purpose and when we work shoulder to shoulder and elbow to elbow with each other, we start to realize we have so much in common. And that gives us the foundation to be able to not necessarily look past differences, but to look at those differences and the diversity that comes to the team because of those differences, and to celebrate those differences. And so the approach that we've taken on the station in the 2 decades of collaboration in space, in the pursuit of knowledge, that's something that we're going to continue to carry forward as we go to the moon, as we develop the Artemis program, when we start to explore the surface of the moon, and as we take what we learned there and we push on to Mars. I think ultimately that's the amazing part of going to space. That's the real motivation. It's such a powerful, positive example of pulling us together and accomplishing something great.
In the coming years, astronauts will continue to push the boundaries of human space exploration. The Artemis program will send the first woman and the next man to the moon. An important part of NASA's Artemis program is setting up sustainable architecture on the moon's surface. Here on Earth, astronauts are already practicing how to move around, set up habitats, collect samples, and deploy experiments just like they will on the moon. We have a lot to explore on the moon and Mars. But the Artemis astronauts' first stop will be the pool.
为什么直接跳2个？
The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is
好
Katie
抽了，
Atkinson.
朋友们，我的手柄
Special
抽
thanks
了
to， Thalia Petrinos, Eric
手柄突然
Land,
发疯
Gary
了，现
Jordan,
在。
Brandy Dean, and Ryland Heggie. If you liked this episode, please let us know by leaving a review, tweeting about it at NASA, with a friend, and join us.
我的手柄突然发疯了，在这里。你看，他刚才我点一个键，他跳2格，突然我靠，微软，你不会告诉我你家手柄会双击吧？ 啊，人家鼠标听说过双击的，怎么手柄也有双击啊？怎么偏偏在这个时候抽呢？而且，哎，我也没干嘛呀。哎，我去！我干脆整个 Steam 我都重进一下，我怕是什么 Steam 手柄、Steam 控制器。好了，真是 Steam 抽了，这不是微软的锅，这是 V 社的锅。Steam 的控制器绝对是抽了，重启 Steam 比一切别的都有用。你说这肯定跑不了，也不知道 Steam 这哪来的 bug， 这直接把手柄给 bug 了。话说，我真的觉得 Steam 近1-2年更新这 bug 很多呀，比以前很奇怪的，我不知道为什么会这样。我遇到过很多次 bug， 像截图它也总出 bug， 而且我最近有的时候截一个图，它会把我的游戏卡2秒，我不知道为什么，有的时候会，有的时候不会，然后这也是 Steam 的问题。然后你看现在手柄断了，也是 Steam 的问题。哎，你们到底怎么回事？为什么 Steam 变得越来越不稳定了？怪错人了。虽然微软的品控一直都很拉。但是这真不怪微软。哦，对，那个还没开呢。我的遥控器，遥控器是在哪里来？这儿。其实我不用上去，我只是要移一下东西，我可以直接开这个。Outpost Universal Stash。身上带这么多枪，靠，是不是有点过分了？怪不得我总超重，靠！我带这么一堆东西。 这余烬说实话真不行啊。余烬这个枪它的电磁伤害实在是低的离谱，我还是放回去。这个电磁武器这一栏我还是用那个斗12分点算了。刚才改的名字应该也已经上来了。孤星针、神殿卡帕。这边还有一个，看看是什么。这应该是孤星针吧。但是我的强迫症让我必须过去看一眼。不知道这游戏最后我会不会能到一个不用修改器把所有技能点满的地步。就是这不用修改器不只包括修改器啊，也包括那个我不能打任何比如说增加经验值的 mod， 我不能打任何什么打敌人多经验值完成，就是经验值系统完全是默认的情况下，我能不能有一天解锁全部的技能的最高等级？我看了别人说解锁全部的技能最高等级要360级，我们现在是130级，还没到一半呢。不过随着你的哨站越来越多，你升级会越来越快，后面升级越来越容易，是真的。我今天就不能把这些凑齐了吗？因为它不是一共有5个异常重力点，我现在凑了3个，我想尽可能早点把这个图鉴做完，所以过去看看这里。哎，这个说实话我也不知道，我要过去再近点。啊，不对，这个就是那个，这是那个青岛之塔。你看，我认得出来，别以为你换个角度就认不出来。每次飞船降落，我就想看。赫拉卡鲁梅，确实是青岛之塔。OK， 我觉得这里就到这里。这个星球我们还有别的神殿呢，毕竟。我们现在可以前去新亚特兰蒂斯，把那几个……等等，我要验证一下邪炎洞穴。邪炎洞穴之前，因为它有个重名序号，我要验证一下那边没有问题。我先去一趟。 你也是斜眼洞穴，哎，不对，你看，真出问题，还好我看了一眼。21-1的话，也就是说，错了。这个才是。21-。这样子等会儿就没有问题。OK， 出发。回到新亚特，等一下，我要把这个星球记一下。等我升啊！
I have something for you, Captain.
地表温度没记呢。这是哪儿来着？这是厄拉赫星。这是什么星系？露娜拉。那拉星25级，Yellow， 它是厄拉赫星。贫瘠，重力0.26，寒冷。-47度，平均气温啊，没有气温，地表平均温度，极端太阳辐射，明白。磁层无氦三铁。
I picked something up for you.
This never gets old. Lift off.
Achieving orbit now.
圣语教朝圣者。
If you don't want to return, I'm making another run out of New to get closer to God.
给你们拍一张。圣与教。
I'm making another run out of New Atlantis, taking universals out in the stars, to get closer to God and to appreciate the galaxy and all its majesty. We grav-jumped to a few different systems. We're lucky to have some pilgrims who have never been off-world. Seeing so many marvels can be a life-changing experience. Space travel is dangerous, but fortunately, most ships don't engage us. Whether it's respect for our religious beliefs or the fact that we carry only passengers, I don't know. Have you ever felt something spiritual while traveling the stars? I've jumped dozens of times, and I still don't know I've had the revelation that Keeper Aquilus describes.
我们想要随时就可以了，朋友们。
I completely. It was a pleasure to. But I hope God watches over you out there in the stars.
让我们回到，让我顺便啊，既然咱们来都来了，那要不就顺便看看吧。他的那颗在这儿佩特里，其实离得挺远，离得都不近，或者说其实这个距离都不算很远。 我想看这个货运箱到底是什么样子的，我从来没有仔细观察过。它是这个怎么我感觉在哪里见过呢？这个箱子在哪里见过？它确实长得像是个普通的集装箱，不过这倒没什么特别。上面有俩编号，仅此而已。有很多飞船零件。佩特里亚星。登记开始。标准甲烷，平均无化学，水，铜，铅，氟。啊 ，XF4是什么东西？四氟化物。水和大气倒是有。降落，先降落到科学哨站。
Landing site looks clean. Let's set it down.
Back, eh? How's it going? Amazed I haven't died of boredom yet? Me too.
它这外面是科学哨站，让我有一种不好的预感。
Last night was enlightening. I hope to.
Lost in my thoughts, but glad to be back.
Even without life, there is the potential for beauty.
话说这边叫科学哨站，难道是因为？我的意思是，难道是因为？难道个毛？难道明明命了名？哇，又来了！知道怎么回事了，一样的问题。我们要先退，否则无法改。看来是一样，我先把这个保存。Starfield yes。可以看到这几个，应该就是这几个的问题。第2012已经改过了，也就是这个。从这个开始，上面漏了，不过这个倒不多，还好。但是我要找到他们几个，并且把他们几个加到 ESP 里面去。我们又要搬出我们的这个 SFE Edit。Science Station， 先找这个。科学不是这个，这是科学星际站。也不是这个，这个有具体名字。科学社，我把这个加进去。我直接拿这个做编号，永远不会错呀。这样才对嘛。我干脆就用这个 ID 给他们编了，否则总是重复，谁受得了？科学基地 ，copy as overriding， 科学哨站，科学哨站2。选错了。 哒哒哒哒哒哒哒哒哒哒哒哒哒。那怎么还叫科学哨站？咦，我没有叫科学哨站的东西。对，我没有叫科学哨站的东西。Outpost。怪，我必须再次开始查看。The hell？003 location 009 006 006 007 007 005 005 025 025 020，少了这个。稍等一下。藏在这里了，这里不止还藏了，这里还藏了一堆其他的呢。大家看 ，activator， 这 activator 藏了不少啊 ，power reactor。但是应该不是会是这个东西吗？问题是，因为这个 T 看起来非常的 generic， 而且 activator 不应该是那个按钮、触发器之类的玩意。不管，我们可以先全部加进去，反正后面可以删掉，无所谓，都加进来，要加一起加比较方便。电荷微粒、建筑公司区、联合手控中心、矿业区。对，这些都是互动的。其实，难道星球表面的那个东西算互动？哎，不是不可能。你别说，还真不是不可能啊。哎，我怀疑这些星球表面那些也是触发点，这就是为什么会出现这种情况。 低色是未知生。Mission marker cargo resource. Extinction event.对呀，它这量。这量太吓人，我不加这些，这些也没必要加。这3个可以。Gravity anomaly。采矿站，采矿站。OK。002 CD 256。002 CD 254。000759C0。研究证000759BF。00070DA6。00070D9D。00070D9C。00070 70924。00070926。00001711。欧裔。Signs Outpost 应该是这个了吧？希望如此。上天宝，哎，对了，朋友们，哎，我们又找到原因了，就是这个就一直 debug 嘛，你看现在就有了，科学哨站000700A6，这就是我们刚才找到的那个。这样子的话，我们就可以定位它的名称所在地，并且给它命名，完美。现在让我们去看看它到底是什么科学哨站。这个地方的重力挺大的，零下44度是吧？没有别的危害，氧气含量应该也是0，因为它是甲烷大气。没有环境危害。还有个被子啊！看看这个地方我们认不认识
What does your scanner reveal?
有没有记过？哦，没有记。 感觉没记过。地点类型。应该没有，确实应该没有。看看这地方是干嘛的。就是研究植物，在甲烷环境下种植物，倒是真有大气，还真能种。也有一些甲烷行星是有生命。我这边一堆多肉植物，一大堆，你可以拿还。那我拿了，我不客气了。别全拿了。但我想再拿一些黑花盆的，我把中间的留给你们，别的我拿走了。查布拉什。
Oh, sorry, I didn't see you there. Am I ever glad to see you? We need your help. Spacers have been demanding protection for weeks now, but we've nothing left to give. Things are about to get violent. Then they get in their ships and leave. Who knows when they'll strike again? Can you take your ship and put an end to it? Once and for all.
啊，我来，飞船站。
Oh, that's great. Thank you.
飞船站越多越好，天清气爽。最终遗言。基本全会写。我的想法就是把所有能写的都写。我这边还有更多的多肉植物，是真喜欢多肉植物。
Yes?
好多
If
多
you
肉。
want to know what we're up to, the little research, I can give you some details. You the new lab rat?
Excuse me.
抗菌植物学家。那我知道我管这个地方叫什么。叫做
Yes. What?
多肉植物栽培室。多肉，他们是生物公司的人。虽然生物公司的你来的话可能不一样，不同的哨站，但是这个应该是能固定。他们肯定都是生物公司的人。我在想叫什么。
You wouldn't take it from me. You don't want to ask anyone around here about their research. They'll talk your ear off for hours. Nowhere you've heard of. My parents raised me on their farm in the Cheyenne system. I traded up when I left to take this job. Our HAB module is state-of-the-art compared to my family's old farmhouse. Nowhere you've heard of. I traded up. It's great, honestly. Better than I was expecting from a job at the research outpost. Science isn't really my thing. But the team's been teaching me all kinds of things. I'll be a real academic by the time I get home. Here you go.
哎呦，他居然卖这个！
This is what I have. Alrighty. See ya. Later.
我的天，4万个礼物，我干嘛？我拿这些东西干嘛呀？9000个适应框架。
I think you may be trying to take a little too much on.
I'm not sure.
Literally.
The research team looking for something.
他没钱了，他穷了。
Okay, have a good.
这些小资源我可以随便拿的，其实。
It's a scouting mission. The United Colonies sent us here to determine whether this planet is capable of supporting human life. I'd be over the moon if our findings led to the founding of a new settlement. What a legacy to leave behind! Ah, a good Samaritan, are you? Lucky me. We're a bit short-staffed right now. There's plenty to be done around the outpost. Our mission board should have all the details you need. Okay.
探查居住条件，这算是事件吗？说实话，星空这一次它的随机事件和实际地点有点模糊的，它不像以前就彻底分开了。哎，这一代我还真不好说。其实我觉得算事件，因为你想啊，这同一个哨站可能发生的事情是不一样，这些哨站应该就是随机事件，像老滚辐射的那种，那我就记一笔，反正先记一笔，又不会。对，这些应该和那个军事训练那种都是事件。只不过这边是那个这边是算低级行星，我干事儿回报比较少。我这个等级应该去一些高级行星干事，那样会比较爽，给的东西会非常的慷慨。
Field work's always been my passion.
你把这门，
Imagine being stuck behind a disc.
这门被他们锁了，靠，进不去。你们真的是，我真服了你们。那么是时候给这个地方命名了。科学哨站2，这个其实是科学哨站2。打开 X Translator。哨站2。外部名称是这个，怎么卡住了？嗯？依据考察植物实验站 ，OK。
Do you see anything useful?
这一上来的落差。我记得这个洞，但是它当时叫什么呢？都可以删掉。根须，好的不，这个不是根须洞穴。牛柱洞穴，硕柱洞穴，这俩应该也不是一个。当时有没有想到什么名字啊？这些都没拍照，鬼知道是什么玩意儿！我靠，该死的，这下难办。从现在开始一定要做好拍照记录，这太重要了。哎呦，干嘛啊？这么细，突然，哦，这个也能吸。那我决定叫虚坑洞穴，25-1。 外部是一样。哎呦我操！我没想开枪，我只是点错。这船，这船怎么长得这么搞笑啊？这两个导弹发射器像两个眼睛一样，也没开门，我上不去。我们先回那个。先回新亚特兰蒂斯，把新亚特兰蒂斯清了，要有个先后顺序。对了，我还要检查一下我的供应链。开始下雪。
Orbital insertion done.
太空劫匪接洽人。
Stop and dance among the stars.
这是地点啊，其实。其实你还能登船，那确实更算地点了。如果是这么说的话。这是不是就是刚才那两个太空劫匪？我在想，就是任务要我打的那俩。
No. I hope you'll give me a holler before you head out again.
这是什么？蒸腾？还是液氮？甲烷水吧？还是什么？我也不懂。
Oh, you're back. I hope this means you have good news.
他们全都踏上单程旅行，
Not
希望
going
你
to
无需
lie,
知
that's
晓
the
这么多。
best news I've heard all day. Here, take this for your trouble. It's the best I can do. Stay safe out there.
还是想过去看一眼。哼，这不会是要沙尘暴了吧？30。中间有个柱子，记没记过去？我怎么感觉刚才好像看到过？这个地方像是塌了一样。这个地方确实看起来地质很不稳定。 30。崩裂洞，崩裂洞，外部30号。这山洞30还是洞穴30是2个，山洞30。它好像四面八方都被崩下来的石头给堵住了。这个洞看起来，你看这里也是，那里也是，所以我决定管它叫崩裂洞穴。这个地方应该发生了一些非常严重的，你看这些地质挤压的痕迹，看上去。山洞 G。
Your abilities are truly amazing.
我现在穿的这一套就跟游戏刚开始一样，你看，穿着一身土矿仔啊，穿着一身这个挖矿服，拿着把万古手枪，别人以为我开了新档呢。这身装备，你要是不仔细，你要是不看它的，特别是宇航服的属性的话，真的会以为我是不是开了新装。还是因为它属性好，我才穿着它，其实。管道终点，这边出事儿。靠，又有2个啊！我要杀人！哈哈，我又命名的时候乱搞了，自作孽不可活呀！真的是离谱。 又来。当时就完全没考虑这个问题吗？我的天！这张照片是我拍的，我还记得。霓虹城这个蔽日区的光照做的太好，特别是那个 Xenofresh 上面打下来那束光啊，这质感。中间是冷光，两边是暖光，层次做的也很好。这是1，确定，1就是1。那反而不是-1，就是之前那个确实写错。叫管下沉管。不要这玩意儿。他是怎么死的呀？寰宇去文，箱子，结果这鬼东西上了锁。你们怎么这帮人都这么不擅长撬锁？看我3下5除2把它撬开。这除了这也不就这么点破烂，你把自己的命都给搭进去了，这人也是离谱。寰宇去文，这可不去啊！ 这外面都裹着这个金铝一样的东西，外面还有一堆保暖的那种棉还是毯什么东西。定居者。
Can succeed at that before we are discovered.
Am I being reassigned? Need something out of my... Stay safe.
我怎么记得之前这屏幕？难道是它适配21:9适配的是这个？我之前感觉我左下就是开扫描仪的时候啊，我左下角的这个表盘其实并没有变暗，但它现在有个暗角处理，我不知道这，我就感觉以前没有注意到过有暗角处理。 不过我反而喜欢没有不变暗的那个，奇怪，为什么会这么明显？这地方绝对记。采矿哨站4。 采矿塔吊，fuck me， 又来了，真的是，我已经恨死我自己了。又是这样子。 知道我买的星空地图什么时候到？ Come to Aquila City. 百光哨站4，看来是真是4。哦，看来并不真是4，因为我每次命名的1都是那个先，所以其实我每一次都错过了，我不知道为什么。Editor ID in progress transferred. 可以回新亚了吗？还是我们继续走？其实都行，因为我们现在其实不用担心资源上限，那个资源基本可以理解为无上啊，其实是有上限的，但是它真的不太可能用得光。我们还不如把这颗星球所有能探的地方全探。 然后再回新亚去整理东西。现在是10点半啊，今天还有的是时间。但是其实甲烷大气的星球我不是很喜欢待，我不知道为什么。就是我不知道有没有朋友有一样的感觉，甲烷大气让我有点觉得窒息啊。当然废话，因为人类不能呼吸，但是就是。 起码是这个游戏，它对于甲烷大气的刻画，就比如说这个盐，这个色调，你看这个色调就是，我靠，这个色调就是那种特别厚、特别浑浊，然后就感觉心里被这个压迫感非常重，所以我不感觉好难受啊！靠，我有一种形容就是梅雨天。 就是让人有一种好像在梅雨天的那种喘不上气来的感觉，我现在就有。 不知道为什么看到这些石头，我突然想起了那个伪装成石头的那个生物。好在这个星球可没有生物。那个怪打人太疼，疼死了。哎，话说，这个东西在空中，因为它不能瞄准，所以不能慢动作呀。我希望以后能改一下，就是这个切割器，它没法慢动作。那你说它有一个瞄准模式的问题在于，哎，不对，不对，是我是不是在？我看看，如果我实际上拿出来，不行不行。它其实有一个瞄准模式的，你看它的光，它打出去的时候，如果是这种橙色、红色光，就是我在那个聚焦模式。如果你打出去是红色，那就是因为红色是低功率，红色的激光是低功率的，然后黄色的是金色的，这个是高功率。但是它确实不能在空中慢动作。最可靠的小手枪。山洞 W 27-1。哇，这个就是那个，这个我知道。这个我们记过，而且它是比较明显的一个，看看我能不能找得到。山洞27-1，而且这个楼柱洞穴，哎，这个好找。27-1，这个特别标志性，特别有标志性。爱国名称山洞 W。27-1。山洞 W。transfer。图都不用再拍了吧？这不已经有图了？其实这两张图，这张倒是更广一点。那也，楼柱洞穴 ，OK， 我们知道这里了。而且我标的是 down， 我已经探过了，我可以走。这边有个大坑。这边有一个超级大坑，大家看到没有？我想过去看看，是哪边？这边。 让我喝口水。哎呦，到了！这是个大山谷，或者说是个大坑，取决于它的边缘是不是合上。不过好像也望不到对岸。所以到底是它是盆地，还是我是不是？我的意思是他，靠，我也不知道，就到底是我在山上，还是它是盆地？这应该取决于哪一个占地面积大吧。目前看来应该是它是盆地，但我也不确定。如果你出去，到底是什么个情况？怎么有箱子浮在空？哇！啊！这怎么掉一个传奇呀？这。深红舰队，我老远就看到了。深红舰队占领机库。立刻换上新防队制服，和他们来打啊！我们才有正当理由连职。新防队放下武器。 不再手下留情。给过你们面子了，已经。
Once again, we are triumphant. I think you may be trying to take a little too much on. Literally.
来了。
A landing ship is cause for concern. You should be on our guard.
这是 Steam， 朋友们，我手柄断了，就像上次一样。你不要在这时候 ，What the fuck？ 真的离谱，什么意思啊？到底是谁的毛病？肯定是 Steam 又抽了。真贱。 小子。Big craze here. Hey! Motherfucker.
Let us try not to be responsible for any industrial-sized accidents while we are here.
Where do you need my help, Captain? What can I take for you? See you later.
I hope you'll give me a... Yeah, I can take it. Bye for now.
The stars for you. But I hope.
你们最好给我识相点，否则你们全都要死。谁说的？我操！你们真是敬酒不吃吃罚酒，我的天！你们不要太过分啊！真的是嚣张至极，太嚣张了。 话说65%。
Your abilities are truly amazing.
像面包一样的地形。拿喷气背包跳坑也挺好玩，因为这代喷气背包的手感非常好，比76进步太多，很顺很滑。这个人，干动 G。
Stealing my take? Just step away from my find. I'll let this go, but don't let it happen again. If you're lucky, you might find another one around here.
矿工。我给它起的名字。我只是看看，我不拿你东西。这不会是那个一线天洞穴吧？3洞20。这应该就是一线天洞穴。哇，这么黑呀！我操，好吓人。哪都有人藏信用币啊，全是走私。我怎么整个星系里全是走私犯是吧？到处都是走私犯。如果这是一线天洞穴的话，我们就把这个加进。但我也不确定是不是，反正先把这个弄掉。20。 20。外部洞顶较高，没错。外部是什么来着？哎，我再出去看一下。靠，迷路了！啊，这边。G。哦，我操！对不起。这个手柄切到鼠标的时候，它就会那个。佩特里亚星。
What does your scanner reveal?
太小。Add property. File and media. 标志性环境。每个星球地表。我们要拍一个这个，以快速知道这个星球上大概什么样子，大概的一个概览就行，倒不用多么详细，心里有个数。因为每个星球它不一定生物群系，它有的星球可能甚至有10种生物群系，有的星球就1种，荒漠荒芜，所以。这些都还是需要注意一点。伪第一人称截图再度出世。斜阳低下， 是西吗？应该是西吧。等等，那个，它那个左下角表盘上的那个白点指的是南还是北啊？应该是南吧？那应该是东。如果我没猜错的话，这废弃矿井2应该是哈哈。
Authorized personnel only.
幽深矿啊，不知道这是哪？深。 幽深洞穴。夕阳西下，真漂亮。底下怎么？
Do you see anything useful?
验证一下。好危险！也太高了。真他妈煞风景，不想鸟。确认。 OK， 飞船来接我吧，我们走了。日落，待了好久。斜阳西下。感觉把我关了更好。哎，把我关了，这照片才。
I picked something up for you.
我每次一要起飞就开始下雨，下雨。
Join the stars.
Apogee kick complete. Orbit steady.
More challenges.
Fine.
You
shit！ 标志性景观，咱们来一张。这里说实话也没有什么特别标志性的景观。
Landing now.
这里太黑了，我们还是找个亮点的地方。找个亮点的这儿。
Landing site looks clean. Let's set it down.
No organics here. Valuable minerals.
这地表一看就是那种火山。一段太阳辐射，谁开的灯？他们在开灯。标志性景观。哎呦，这个地方挺重力。
I found something for you.
我溜了，你来了，我走了。
Lift off initiated, Captain. Time to venture into that beautiful sky.
Retros firing. Orbits.
让我回到水星，因为既然要整理的话，那当然是从一个地方开始了。太阳系，既然我们整个这个 mod 都要重新来做的话，那么就从水星开始，理所当然，一个个星球咱们过去。站我前面干嘛？你站着干嘛？怎么了？干嘛，安德烈亚？这样不好，你这样危险驾驶，我有盲区了喂，我盲区太大了，你给我，你不要站在我旁边了，拜托。 可真是够狠。水星，我们先把这3个地点实际上测出来。
Landing site is clear. Let's head down.
来站这儿。
Lost in my thoughts, but
我去，这可不姓水，这是鬼水星的那个。
If I can help you,
这个不是啊？对，我查查，水星是水星。 轨道周期87.969日，水星确实是。 并非1:1潮汐锁定，是3:2轨道共振。天文学家原本以为水星是被太阳潮汐锁定的，但其实并不完全是，其实是水星每公转2.1圈，自转3圈。它之所以有自转，科学家们多认为水星以前遭遇过较大天体撞击，破坏了它被太阳锁定运行的姿态。哦，原来是这样。 今日小知识，我也以为水星是潮汐锁定的来着。这些调都能哼出来。看这些星星交织在一起的样子，假的星星和真的星星。一闪一闪，摄影师。 Hello， 摄影师，我来和你打个招呼。
I don't take photos of people. Sorry.
这摄影师笑的，没刷完，快了，不过。乐。 太乐了，他来得及。我感觉我现在多少级？我快了80级，好像。爱好拍风景照，不拍人物照。 不拍人物照的摄影师， 的眼睛。这个地方，这是哪一个来着？坠剑求生营地死结，坠剑求生营地没错，坠毁地点1。等等，这不是飞船残骸，这不是坠毁地点吗？问题是。无尸体1号。我又给搞成这副样子，又命名重复了。解决，总给自己埋雷，哎。679小时了，679。今天晚上680。不过按我们大概每周10到15小时的星空游戏时间来看，700小时应该要等到下周才可能。不会那么快。